So today we're starting our next packet. We're doing assignment 26. Now we're still graphing, we're still using tables, but this time we're working on exponential functions. Don't worry, I won't make you do any in delta math. You know it's exponential. This whole packet is exponential when the x is in the exponent. If it's anywhere else, it's not exponential. So on this page, we're going to be graphing, and I'd like you to do it on paper, or you can use your Cami option. So our first problem is 4 times 2 to the x. Now, on this paper, they use a dot, but I always put it with a parentheses on my calculator because that's just the way I type it. So to save a little bit of time, what I did was I already typed this into Desmos. And hopefully you can see up here, is it letting me write? Yep, there it is. There's my problem. So it's y equals 4 times 2 to the x. And then I already set the table up. So my table is going to go from -3 to 3 for all of these problems. So now what I'm just going to do is copy down my y values. So over here, make sure you copy this table down. If you need to or want to, go ahead and put in a skeleton of each table to save time, or pause this and then come back when you're ready to write the next part down. So this is 0.5. And remember, I just copied that from the table that was on Desmos. And now I'm going to plot the points that I can plot. I can do -3.5. That's about halfway up from 0 to 1, -2, 1, -1, 2, 4. Now 3, it's not 313, that is 332. This one will not fit on the graph. That's okay. We don't have to plot it. We can just leave it there. Now, you guys know how these graphs work because you've had to deal with it on delta math. Just make this go. Make sure it does not go below that x-axis. And there we go. So let's go to the next one. Okay, I've got my table ready. Our problem is y equals 5 times 2 to the x. So now watch what happens here. We're going to go to Desmos. I'm going to keep this. The only thing that changes is this 5 right here. So let's see if it'll let me do it. First, I'm going to try to get rid of this circle. Side, there we go. Now, it's not letting me do it. So I'm going to go over and type, and instead of a 4, I'm just going to change this to a 5. And look, the numbers changed. So I'm going to copy those down onto my table and then plot the points that I can plot. So this one, I'll do this one in blue. 0.625, 1.25, 2.5, 5, 10. Oops, that wasn't very good. Okay, there we go. I'm trying to move this down. Okay, so now I'm going to plot these. This one is just a really small number, -3.625. So I'm just going to plot this and make it as close to the x-axis as I can. -2, same thing with this one. Okay, I'm not being exact. I'm just doing my best there. Now, -1, 2.5 is between 2 and 3. 0.5, 1, 10, 2. Okay, I could do 220. That's up there. So now I'm going to connect. Start off as small as you can, but don't go over the x-axis. It never goes over the x-axis, actually. So now what I would like you guys to do is try these on your own. I'll show you how to type this into Desmos, and then you're going to work on these. So I'm going to change this to a 4. And to turn this into a 1/2, I'm going to click on this, do 1 divide by 2. Divide by makes a fraction. So you are going to go on Desmos and you are going to do these, graph them, and then come back and check your work. All right, so here's what my graph looks like. I copied my table down and then I plotted my points. This one is actually called decreasing because it's going downhill. Now for the last one on this page, again, you're going to do this. You're going to put this into Desmos, 2 times 1/2 to the x, fill in the table, and then plot your points. Pause this and then come back. So once you do this, these are the points you get. That's a 4, 0.5, and 0.25. Okay, -316, -2e4. Small, small. Okay, and there's our graph. So I'm just going to zoom out so you can see all these. Okay. They all kind of look the same. The only difference is sometimes, oops, oh well, that was no good. Son of a gun. All right, we're just going to go right there. Side. Sometimes it's increasing, and sometimes the graph is decreasing. So now that's going to take us to the next page. Okay. These 3 problems, we're actually going to go back and forth. This is going to be the same for all of these. So I'm going to look at the first graph just so we don't have to keep zooming out and looking at all of them, but they are the same for each graph. So the first question says, what are the x-intercepts? So when we look back at this graph that I totally screwed up, I think it's like this. An x-intercept, remember, is where the graph crosses the x-axis. For exponential functions, there are none. So we're going to write here, there are none. Exponential graphs never cross the x-axis. Lunchtime. Do not. And just because, I'm going to draw a quick picture. So you've got 2 options. So your graph can look like this, or your graph can look like this, going down. But in both cases, it never goes below that x-axis. Now the next one, if you look at the y-intercept, where in the equation can you find the y-intercept? Now this is something hopefully you can keep track of and remember. I have to shift this back over because I did screw it up. So this problem, I'm going to rewrite the equation here. Y equals 4 times 2 to the x. This first number right here is the y-intercept for every single problem. So if you look at that number, it's going to correspond with where the problem crosses the y-axis. So for our answer here, I would say the y-intercept is the first number in the equation. Now, of course, in math, there's always things that are a little different, but for the most part, it's the first number in the equation. And now the base, the number in parentheses. How is it determined? So this is what the y values are multiplied. So I'm just going to say this is the multiply rate. And then we're going to do one more problem. If you need to, you can pause this, rewind it, make sure you get this filled in. We're not doing number 8 because the points don't quite line up. This graph isn't perfect either, but we can roll with this. So we're going to make an equation. Here's the point, and it's not perfect, but I would like to make this point right here. So our first point is 0, 2, and then this one is 1, 6. So the x is always counting up by ones. Now, because there's so many graphics here, I'm just going to rewrite this. 0, 2, 1, 6. Okay, our x's are going up by ones. What we're looking at now is our y value. And it's always multiply. 2 times what gives you 6? And the answer is 3. That's our multiply rate. So to make our equation, first we need the y-intercept. That's right here, 2 times our multiply rate to the x. We will practice more of this on Delta Math. So for now, you got to have up to problem 7. Actually, it's exercise 3, problem 7. The last one we're skipping. And then I will see you all in class and we'll do some more